I'm John Kissinger. Let's do some math. Whole numbers are the kinds of numbers that you would use to answer questions like, how many days are there in a week? How many days are there in a month? In February, for example, there are 28 or 29. How many cars do you have at home? How many computers do you have at home? How many horses do you have at home? There was a time in the United States when most families had at least one horse. So it could be any of these numbers. But nowadays, most people don't have a horse. So for most people, the answer would be 0. But all of these questions can be answered with whole numbers. If you take, for example, how many days are there in a year? The answer to that is approximately 365.25. That is not a whole number. So this is an example of a kind of question that cannot be answered with a whole number. Now, I want to look at a specific subcategory of whole numbers, namely even numbers and odd numbers. Even numbers are interesting because every even number is a multiple of 2, meaning that if you take 2 times 1, that's 2. 2 times 4 is 8. 2 times 0 is 0. 1, 4, and 0 are all whole numbers. And what are we doing? We're multiplying them by 2 in each case, and we're getting these numbers. Any even number, for example, 100 is 2 times 50. 1,000, for example, is 2 times 500. So any even number can be found by multiplying some whole number by 2. Now, an interesting thing about that is that if we are doing algebra, for example, we use shorthand. In shorthand, instead of writing all of these numbers like in a list such as this, if we just use this shorthand, this expression, 2 times n, where n represents any whole number, we're already writing this entire list, because n could be any of these numbers here. If n is 0, 2 times 0 is 0. If n is 2, 2 times 2 is 4. If n is 5, then 2 times 5 is 10. If n is 50, then 2 times 50 is 100. If n is 1,000, 2 times 1,000 is 2,000. So any even number can be written as 2 times n, where n is a whole number. Now, the other interesting subcategory of whole numbers is odd numbers. The odd numbers are in between the even numbers. So, if you want an even number, you can either add 1 to an even number or subtract 1 from an even number. If you want 5, for example, take 4 and subtract 1, and add 1. If you want 9, take 8 and add 1. So if you use the shorthand notation, 2 times 2 is 4, plus 1 is 5. If you want 9, take 2 times 4 is 8, plus 1 is 9. Or take 2 times 5, which is 10, subtract 1, and you get 9. So either by adding 1 or by subtracting 1, you get odd numbers from even numbers. Now I want to look at the effect of even and odd numbers on negative numbers. Looking at the negative number unit, negative number unit. What does that mean? Every negative number, negative 100, for example, can be constructed by multiplying negative 1 by some whole number. Negative 5 is equal to negative 1 times 5. Negative 27, for example, that's negative 1 times 27. Any negative number can be is the product of negative 1 and some whole number. But what is the effect of raising a negative number to an even or an odd exponent? Negative 1 squared, for example, is negative 1 times negative 1. Now we know from the multiplication and division of signs that when the signs are the same and you multiply them, you get a positive result. So this is going to be a positive number no matter what. We know also that 1 times 1 is 1. So a negative 1 raised to an even power gives you a positive result. Let's look at a different one, negative 1 to the 6th, for example. That's another even number. How can we get this from that? If we use what's called the power rule, negative 1 squared, and raise that to the 3rd, since in the power rule you have an inside power and an outside power, in effect you're multiplying the powers, but we already know what negative 1 squared is here. So that's going to be positive 1 cubed. But what is positive 1 cubed? Well, let's look at negative 1 cubed first. Negative 1 cubed is negative 1 times negative 1 times negative 1, right? We know from here that negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1. Back to this. Any positive number multiplied as many times as you like is not going to change the sign. So this is going to be positive 1 no matter what. Similarly, if you have a positive number and you raise it to an even power, it's going to be a positive. So positive numbers don't change sign no matter what. If you have a negative number, though, we already saw that with one negative, you have a negative. Does it change if it's a 5, which is another odd number? We can get negative 1 to the 5th by taking negative 1 to the 5th times negative 1 squared. We know from the product rule that when you multiply two expressions like this, you add the powers, right? We know from this here that negative 1 cubed is minus 1. We know from that this is positive 1. Negative 1 times positive 1 is negative 1. So we saw two examples of raising negative 1 to an odd power, you're going to get a negative 1. This is the same for every situation because you can build a negative 1 to an odd power from either an even or an odd. Let's look at one situation. How much is negative 1 to the 2 times n? Negative 1 to the 2 times n could be rewritten as negative 1 squared raised to the n, using the power rule again. But we know that from before that this is going to be plus 1 raised to the n. If the sign is positive, no matter what the power is, it's going to remain positive. Let's look at the other situation. Negative 1 to the 2n plus 1, for example. Now, we know from the product rule that this can be rewritten as -1 to the 2n times -1 to the 1, right? -1 to the 2n we saw already is +1. -1 to the 1 is the same as just -1 without the power. So that's that. And that's going to be a -1. So this is the general case of raising a -1 to an odd exponent. It's going to be -1. Similarly, we can look at -1 to the 2n minus 1, which is -1 to the 2n times -1 to the -1. But what is that? -1 here, this is -1 to the 2n times 1 over -1 to the positive, right? We saw here that this is +1, and we're multiplying by 1 over -1. Dividing a positive number by a negative number is what? A negative number. So this is a -1. So in every case, raising a negative number to an odd power, positive +1 or -1, is going to give us a negative. Raising a -1 to an even power is going to give us a positive number. Now, all of this and much more is covered in the workbook series that's linked to in the description. Thank you for watching.